Q8879. When using an electrical connector exposed to moisture, what type of connector should be used? A. Coat the connector with grease. B. Use a special moisture-proof type. C. Spray it with varnish or zinc chromate. The correct answer is B. When using an electrical connector exposed to moisture, it is important to use a special moisture-proof type of connector. These connectors are specifically designed to provide protection against moisture ingress and ensure reliable electrical connections in wet or humid environments. 8880. Which of the following are considered circuit protective devices used in aircraft electrical systems? A. Circuit breakers, relays, and current limiters. B. Circuit breakers, fuses, and current limiters. C. Circuit breakers, capacitors, and current limiters. The correct answer is B. Circuit protective devices used in aircraft electrical systems include circuit breakers, fuses, and current limiters. Circuit breakers. These devices are designed to protect electrical circuits from excessive current. They automatically open or trip the circuit when an over-current condition occurs, such as a short circuit or overload, to prevent damage to the circuit and its components. Circuit breakers can be reset after tripping. Fuses. Fuses are another type of overcurrent protection device. They consist of a thin wire or strip that melts when exposed to excessive current, thereby breaking the circuit. Fuses need to be replaced after they blow or open the circuit, as they do not reset like circuit breakers. Current limiters. Current limiters are devices used to restrict or limit the flow of electrical current in a circuit. They are often employed in starter generator circuits or other applications where high current conditions can occur. Current limiters help prevent damage to circuit components by keeping the current within a safe operating range. 8881. If a wire comes in contact with moving parts of an aircraft, what protection should be given to the wire? A. Wrap with soft wire solder into a shield. B. Wrap with friction tape. C. Pass through conduit. The correct answer is C. If a wire comes in contact with moving parts of an aircraft, it is important to provide protection to the wire to prevent chafing or damage. Passing the wire through conduit is a suitable method to protect it. Conduit is a protective tubing or channel that surrounds the wire, providing physical protection from abrasion, rubbing, or contact with moving parts. It helps to minimize the risk of wire damage and potential electrical failures due to chafing. 8882. In the American wire gauge, AWG system, the number assigned to a wire size is related to its A. Combined resistance and current carrying capacity. B. Current carrying capacity. C. Cross-sectional area. The correct answer is C. In the American wire gauge, AWG system, the number assigned to a wire size is related to its cross-sectional area. The AWG system is a standard for specifying the size of electric wires and is widely used in North America. As the AWG number decreases, the wire size increases. This means that a higher AWG number indicates a smaller cross-sectional area, while a lower AWG number indicates a larger cross-sectional area. The cross-sectional area of a wire is an important factor in determining its current, carrying capacity, and resistance. Generally, larger wires with a greater cross-sectional area can carry more current and have lower resistance compared to smaller wires. However, the AWG number itself does not directly indicate the wire's current carrying capacity or resistance. These factors depend on various other factors such as the material of the wire, insulation, and the specific application requirements. 8883. What is the voltage drop for a number 18 copper wire that is 50 feet long and carries a continuous current of 12.5 amperes? A. 1V. B. 4V. C. 4.025V. The correct answer is C. To calculate the voltage drop for a wire, we can use Ohm's law, which states that voltage drop, V, is equal to the product of current, I, and resistance, R. First, we need to determine the resistance of the number 18 copper wire. The resistance of a wire can be calculated using the formula R equals rho asterisk L slash A, where R is the resistance, rho is the resistivity of the wire material, copper, L is the length of the wire, and A is the cross-sectional area of the wire. The resistivity of copper is approximately 1.7 times 10 to the power of negative 8 ohmmeter. For number 18 AWG wire, the cross-sectional area can be obtained from standard wire tables. The cross-sectional area for number 18 wire is approximately 0.823 mm superscript 2, or 8.23 times 10 to the power of negative 7 m superscript 2. Now we can calculate the resistance. R equals 1.7 times 10 to the power of negative 8 ohmmeter asterisk 15.24 meters slash 8.23 times 10 to the power of negative 7 m superscript 2, R equals 0.313 ohms. Next, we can calculate the voltage drop. V equals I asterisk R. V equals 12.5 amperes asterisk 0.313 ohms. V is almost equal to 3.913 volts. Therefore, the voltage drop for a number 18 copper wire that is 50 feet long and carries a continuous current of 12.5 amperes is approximately 3.913 volts.